Hello and welcome. Today we're going to go over a weird function. We are going to increment the derivative of g of x as x increases by 1. G of x will be a cubic function such that g of x is equal to ax cubed plus bx squared plus cx plus d. And the challenge is to make it continuous on the closed interval 0 to open interval 4, because after that point, y is equal to 0. Here are the incrementing derivatives. We can solve these equations by substituting the values of x. We have to set f and the first derivative equal to each other at 1 so that they become continuous. Then the second and the third. Notice, because the next two derivatives have to be equal at x equals 3, we cannot make this function differentiable. The second and third derivatives cannot be equal to each other at x equals 2 and x equals 3. Now that we have our equations, we can use a system of equations and solve for a, b, and c. Let's allow a to be 1. We get the resulting equation, x cubed minus 6x squared plus 12x minus 4. I find the graph to be satisfying too. Notice this wasn't a fluke. Changing b or c values do not allow continuity. Let's kick it up a notch. What about any degree function? Oh boy, that looks complicated. Maybe we just do a fourth degree first. I'll just solve these in the background. And for a kick, here are the values of the fifth degree. Notice anything? There seems to be a clear pattern. Let's decipher it by looking at what each step looks like. Here are the patterns I found. Let's subtract the even functions by the odd functions to get the equations. I went out on a limb here to guess what the fourth equation looks like. These are the numbers it gave me. And these are the numbers I should have gotten. I guess it's divided by 6. Continuing this pattern, I create a function that reflects the coefficients, where x is the derivative and n is the current term. Let's go big. A 10th degree polynomial. I'm going to create a matrix using this equation. Note, I did use x equals 1 as the first row. One scary thing, when I coded my program, I accounted for the shift by indexing further in the matrix. But now my function doesn't reflect the matrix correctly. We can fix this by setting n equal to n minus x minus 1. Now the function looks hideous, but at least it reflects the matrix. And here is the equation. Thank you for your time. Stay a little longer to see the graphs of the functions from 1 to 12.